All right, so welcome. My name is Mahmoud Abdelghany. I'm gonna tell you some stuff about my project porting Doom to Doom 3 to Java. Um, and okay. Oh. So a brief introduction about some background about concerning the project. So id Software is a company that created Doom. I don't work for them, unfortunately, but. So they did some cool games, a lot of cool games actually. They're quite known for the whole first-person shooter thing and Doom and Wolf and Quake and that kind of stuff. So probably you know them from that. Another cool thing they did is, sorry, is they open sourced almost everything they created. That's pretty cool. It's pretty I don't know. It's progressive. I mean, most of these games, okay, so you can ignore the first couple of games, but Wolf, Doom, Quake, they're, triple A games actually. So to open source something like that back in the 90s, it's pretty interesting. So everybody has hacked Doom and the such and modded them and to oblivion, and it's amazing. A very different era. They come from a very different era. From the 90s. Anybody here has lived through the 90s prior to, Stack Overflow and shit. People just reinvented the wheel all the time, and interesting stuff came from that. And you see a lot of that stuff, if you look at source code like this, or Linux kernel source code, or any source code that's existed for a long time, you see a lot of this kind of stuff. To demonstrate that, I have a nerd rage anecdote that's nothing to do with me. But back in the 90s, after they released the source code of Doom, people, were looking through the source code and code reviewing the source code. And somebody, he noticed the way asset loading worked in Doom was basically you have a large file, and if you want the picture of the Doom guy, you just iterate through the whole file until you find the Doom picture and you load it. You want the sound of the shotgun, you just iterate till you find, and such, etc. And, when I'm telling it right now, everybody thinks that's very inefficient, and that's what the people thought in the 90s. And they got angry and mad and went on mailing lists, which was the Facebook of the 90s, and started ranting about it. And this is not how it's supposed to be. Everybody knows this kind of stuff. You put it in a hash map and such, or a hash table. And the Doom guys themselves, they were also on the mailing list, and they replied, no, we really worked on this hard. We thought it out and we tested it and that kind of stuff. And this is the most efficient way to do it. Well, nobody really believed them, but it turned out they were really right. So this was the easiest way to do it, but it also used the least resources. So back in the 90s, disk space was a problem, memory was a problem, CPU was a problem. So creating a hash table for something like this for all your assets, I don't know, maybe it was a couple of hundred bytes. I'm not sure how much it would be, but it's memory you don't have. So this was the most efficient solution for the game, And if you put it in a hash table, maybe your game would load faster, but it would be marginally faster, and who cares about that, It's better that the game run faster than load faster, So that's so I really like that story, because what the story to me at least demonstrates. I was discussing this with a friend of mine, and he told me, yeah, premature optimization is the root of all evil. And sure, but to me it really signifies something like how many of us actually do de-optimization to optimize something else, Most of us just optimize a place and then forget about it and then optimize the next place and such. But how many of us actually de-optimize something to gain performance somewhere else? So that's interesting. So yeah, Doom 3 is the name of the project, the Java version of it's up on GitHub and such. I've been working on it, I think now for 4 years or something. It's, to me, at least, it's amazing. It's a lot of code. If you look at the table below, so that's kind of the evolution of their engines, game engines over time. So this is the first Doom, 40,000 lines of code. id 4, that is this one, Doom 3, 600,000 lines of code. So that's amazing. So I've worked on 600 lines of code in a single project. I hadn't done that before. And one of the most amazing things I learned is, you know, I always thought, you know, some programmers were super geniuses and they could, you know, fit a million lines of code in their heads and just remember every part of it. But after working on this and after reading some stuff the guys that worked on this talked about, they had the same problem I have. I couldn't fit all this in my head at the same time. And this, I've been programming for 20 years. This is the first time, you know, in my career that I've really encountered such a large code base for a single thing, you know. So as you see, you'll see in the demo at the end, you know, some stuff is just broken, and that stuff was working, I don't know, months ago, but now it's broken. And to fix that, it was probably, you know, a very simple fix, but I have to. So some of the sound is not working properly, for example. But I'm doing a lot of graphics bugs right now. So if I have to switch that context, you know, I lose all the graphics. It will take me about a week to just switch the context, and then to lose all the graphics knowledge I have at the moment and such. It's kind of annoying. So, but you know, so why this cool intro? So the intro is to give you a bit of a context switch, actually, since we just mentioned that. So this is all very game-oriented, you know. It's not game-oriented in the sense that we're gonna, you know, describe how games are made as such, but a lot of the stuff that's gonna be presented here, or I'm gonna rant about actually, might not really be interesting to what we do in our day-to-day jobs. You know, so I don't know, operator overloading. Who cares about operator overloading for a Java enterprise application, for example? But for games, they're pretty cool. They're pretty interesting. They're very important. You know, they reduce errors, reduce bugs, and that kind of stuff. So, so that's basically this whole intro. Also to you know, just waste some time. So yeah. So disclaimer: I'm not an expert, of course. I didn't work on the original Doom. I'm not a Java architect, that kind of stuff. So take everything I say with a lot of grains of salt. And if anything is interesting, just test it out yourself first before just believing it, like people tend to do at conferences. So the first part of the talk is basically some stuff, you know, so you're porting a lot of C++ to Java, and you miss a lot of stuff in Java, and you just want it there. Maybe it's cool to have it, maybe it's not cool to have it. Some people disagree with most of what I say, and a lot of people just think I'm plain stupid. Yeah, so Bjarne Strauss, for people who don't know who he is, he's like the James Gosling of C++. So imagine him saying this about his own language. It's pretty interesting. So, sure. So yeah, so I'm gonna start out with overloading, and this picture is, you just have to love, you know, the level of innovation and creativity of humans. So yeah, so operator overloading. Java doesn't have operator overloading. What is operator overloading? In some languages, like C++, obviously, you can define you can define any kind of object. You can say, if I use an operator like plus or equals or whatever with this type of object, with another type of object, so type object A plus B, for example, you should, you know, add the members or multiply them or whatever you want. So, like I said, this might not be very interesting for our enterprise applications, but for games, you know, games, especially 3D graphics games, are basically just math. You know, a lot of math, you know, a lot of 3D space geometry math. So, you know, you want to define matrices and vectors and curves and whatever, and you want to, you know, do math on them, obviously. And so yeah, so the first one, so the one on top, so that's from a paper Guy Steele wrote. He was one of the original Java architects. It's a long paper, but this was one of the things he said is basically, yeah, we want operator overloading in Java and future Java. But then Guy Steele disappeared and nobody knows where he is, so I don't know. But yeah, the first line of code, so this is basically the line of code from the C++ version. And the one below, that is how I did it in Java, you know. So I chose, you know, to prefix anything with this lowercase o, that would mean it's an operator, and then a multiply, plus, minus, whatever, as such. And this is basically, yeah, okay, so maybe it's not the best way, I'm not sure, but to me it was the best way, it worked. And yeah, I find it, so I created this and I think this is shit, you know. So this is just not readable, it's very error prone, this kind of stuff. So I showed this specific one because I had a bug in this. I spent like 2 weeks chasing it, and it was basically one bracket that was too far. And it just happens, you know, it's with the one, you know, on top and one above, you know, it's much easier to find those kinds of bugs. Yeah, So this is a simple example of what I mean by these kind of bugs. So this is, you want to do this kind of operation in C++, yeah? So this is how I first wrote this kind of stuff in Java, but this is actually wrong, So anybody who's, familiar with these kind of bugs. So because you have operator precedence, if you do it like this, you add A to B and you multiply the result by C, but that's really not correct. So this is how you actually should do it, Yeah. And it's not readable anymore, I know, but yeah, so that's... And this is, kind of like what the compiler does, but it's still not readable, it's still whatever. So that kind of stuff. Oh. Okay, whatever. So, yeah. Then the next one. Yeah, I had a big picture, but we have no internet here, so that. So the next one is unsigned primitives. So Java doesn't have... So Java has a char, character. That's an unsigned primitive. But, if you do math with char, then there's something wrong with you. So Java doesn't have other unsigned primitives. It doesn't have the unsigned keyword, which you do have in C++ and a lot of other languages. Or in some languages just have an unsigned type, like uint, for example, which means unsigned int. And it's basically, an integer with only positive range, So double the range, but, just shift it forward. So instead of 0 to 2 to the 31st minus 1 or something, it's just the full range, yeah? Java doesn't have that because I don't know why. Actually, I do know why, but it's a long story. So yeah, so the simple solution is just, to use so first, this one, actually. I love this one. This will compile, and this will run, actually. It will, throw an exception when you get here, of course, but it will compile. Why? Because it's valid Java code, An integer array, any array, takes an integer, not a long, an integer, as its size. So yeah, it can be a negative number. Sure, whatever. Nobody thought to check this or throw an exception when you do this, but okay. Oh yeah, so the simple solution for using unsigned integers, and again, this might not seem important, but in games this is very important, And in other types of stuff, like when you work with electronics and such, we just want to wrap around stuff, and you don't want a negative, and you have to bit mask it and such, and it's very annoying. So, yeah, the simple solution is just, to use the next primitive over. So if you need an integer, unsigned, you use a long, But if you need a long, an unsigned long, then you're, fucked. So, yeah, there's no solution for it. So yeah, and of course, when I came across this problem, the first thing that came to my mind, which I know some of you are thinking, is, hey, use big ints or big decimals and such. And yeah, I really thought it was a good idea at the time, and I did a lot of refactoring, just trying this out. But then your memory footprint just quadrupled, for no apparent reason, and it got slower and such. So you see some benchmarks, simple benchmarks, just that simple loop over there. And you just note, even a difference between int and integer, which is basically the same thing, but an object. There is a difference there, and you think about it, for a game, for stuff that has, I don't know, thousands and sometimes millions loops, iterations per second. This is not cool, So if you do this once for a microservice or whatever, who cares? So yeah, micro benchmark, yeah, cool. Yeah, not sure why this picture loaded, but okay. So yeah, immutability. Java doesn't have immutability. It does, kind of has immutability, but it doesn't have something like, in C++ you have const. You have a keyword called const, and just put it in front of something and it becomes immutable. It's like magic, yeah? We don't have that. We have final. It doesn't do anything. It just appears to do something. Yeah, okay, so to be fair, final, it's supposed to do something else. It's not supposed to do this. It's not supposed to replace const. But I don't know, if you look on older Stack Overflow posts, or I don't remember what we used to do before Stack Overflow, but if you look in older literature, so to speak, everybody says, no, we don't have const in Java, use final. As if this is supposed to, substitute const. Absolutely not. And ironically enough, const is a reserved keyword in Java. It's never going to be used, I think. I hope it's going to be used. But so these are some examples. I'm going to go through one or two of them. But oh yeah, and const in C++, when you put it in front of something, it not only becomes immutable, it becomes an immutable type. So const in this case, for example, in const idvec3 is not the same as an idvec3. It's kind of like a different type. So you can't pass a normal idvec3 to this function. Granted, so C++, when you get that low level, you can do anything and you can, work around anything. So you can work around this stuff. But out of the box, this is how it's supposed to work. And get dimension, for example, you can define a function const. In Java, you only define a function final. It can be overridden, which is cool. Can be helpful, I guess. But in this case, this function is not allowed to change anything within the object it's called from. So this is a read-only function. You're just looking at the interface. Hey, this function is read-only. So it's also cool. We don't have that in Java, but maybe sometime, maybe we will have that kind of stuff. So yeah, final. I'm not going to rant about that because just that. Yeah. So another operator another functionality that we don't really have in Java out of the box is size up. And I know this seems like a useless operator, really useless functionality. But for this game especially, we're doing a lot of OpenGL. And OpenGL has to know the size of everything that you pass it. It can't just give it an object and say, okay, this object, just use it and such. No, you have to give it, I don't know, 5 bytes and say, hey, this thing is 5 bytes. So that's how OpenGL works, and you can't change that. Maybe somebody someday will, but currently, no, this won't change, because OpenGL is basically talking to the hardware. So this is a hardware interface, and how to change that is not really, sane actually. And why would they? People aren't complaining about this. We're the only ones complaining about it. But you don't have that in Java. And yeah, so a simple solution for me at least was, to just define bytes in every object I create. This is actually something Java already has for most of the stuff that's in Java. So if you call integer.bytes, you will get 4 bytes back, or float.bytes and that kind of stuff. So I basically just stole it from them. And I do like a kind of inheritance in that, So this one has this kind of stuff, and it calls the idvec and whatever byte. So yeah. So I'm gonna rant about this real quick, because last time I ranted about this so long that I ran out of time. But enums in Java are wonderful things that have absolutely nothing to do with enums. And this is very weird. So the thing above, the foo. So this is an example enum of everything you could do with an enum within C++. And this is actually the only thing you can do with an enum in C++. I know C++ has an enum class, which is something different, but this is the enum, the basic enum, the primitive enum, so to speak. And this is all the stuff you can do. You can just define values out of order, and you can repeat values. So I think E1, or E is 1, and B is also 1, so who cares? And this is the only thing enums can do in C++ and some other languages. And this is the only thing you can't do with enums in Java. And I find it very curious. What you can do, so I tried to write the worst enum I could think of. You can do amazing stuff with enums. You can, extend them. You can, what more can you do? You can create abstract functions, You can create public functions, normal functions. You also can create static functions. I don't have any static functions. You can serialize them, whatever, You can do amazing stuff with enums in Java. But the very simple, basic idea of giving enum a value, you can't do that in Java, which is very strange. And because you can't do that in Java, you get this kind of stuff. You always have to call ordinal if you want to know the order of, or the ordinal actually. So the order of the enum within the, I don't know, the collection, the enum sequence or such, and that kind of stuff. And this is strange. I'm not going to rant about this anymore, but it's just weird. Another thing is how inheritance works in Java, because Java has what's it called, type erasure or something, one of those erasure things. You can't. So another common pattern in games, at least, is you have a lot of single inheritance, and so you have sorry. So we have, like a grandchild object, and it wants to call the superfunction of its grandfather, but skipping the superfunction of its father. So you want to call the super.superfunction, basically, Java terms. And that's not possible in Java, in that specific way, And that's very annoying. So you have to, work around it. So in C++, you can just call it like the one on the right. In Java, you have to be creative and, overexpose the function in the father or something. So, yeah, it's weird. Yeah, so pointers, of course. I usually start with pointers, but I thought, let's do it different this time. And cool picture. It's kind of readable. So yeah, Java doesn't have pointers, of course. At the beginning of Java, people were proud that they didn't have pointers, because all C++ developers, the new C++ developers, they always, fucked pointers up, When they had to create pointers, they just, they either allocated a pointer, never freed the pointer, or it was just annoying stuff. And Java doesn't have that, of course, so it's annoying. But Java does a lot of stuff for you in return. But you lose a lot of benefits as well, So I have a slide near the end, because you don't have pointers, some debugging becomes very difficult. So this is a common pattern in Java and C++, for example. The equivalent of this in other programming languages would be if you want to have multiple return types, so like in Python or Go or whatever. So Java doesn't have multiple return types, and it doesn't allow pointers. So how do you deal with one method that gives you more than one thing back? So yeah, my simple solution is the one below, of course. It's just creating a lot of one-element arrays, and just give the array and just get it back within that and such. And it's not very nice, but it's better than creating a whole wrapper object and such. So I like this approach. So yeah, another cool thing with pointers is you can basically just cast stuff to other stuff. So here, for example, you have a 3x3 matrix, and you say I want a float pointer from that matrix. And in C++, you just say, okay, just cast this address to a float pointer, and it's 9 positions, 3x3, and just get that back. In Java, you have to be creative and do this kind of stuff, Why this is important? OpenGL, once again. Yeah, I'm gonna skip that one. Oh yeah, so this is the only pointer we have in Java, which is very annoying, I think. So it's like getting none of the benefits and only getting the the price you pay. So no null pointer exception. So this is very annoying, and it should be called null reference exception actually, not null pointer exception. But that's also a different story. So yeah, so that's basically all the cool stuff we don't have. Wish list, hands. So yeah, but yeah, C++ is not the best language in the world, of course. They have a lot of stuff I came across. So it's just shit, And yeah, so let's. Anybody know the answer to this one? Okay, nobody. So C++ and a lot of languages have macros. And at the beginning of Java, or at the beginning of the 2000s at least, I can remember a couple of guys or a couple of people wanting to introduce macros in Java. And I'm really grateful they never succeeded, because macros are very strange. They're somewhere in between everything, So macros, so what is a macro? What does a macro do? So here you say define square x. So that's the definition of the macro. You say I'm defining, when I call square with anything as x, I'm going to return x times x. That's basically what a macro is. It's search and replace. Huh? This is not code. This gets search and replaced before you compile. But it's readable for people, and it's easy sometimes. And you can do anything with this. You can define constants, you can define functions, you can define parts of a function. You can do magical shit with it. So this is a simple example of why you shouldn't use macros, yeah? So this is on, I think I got this from Stack Overflow. So when you see this, square x plus plus, what do you think will be the result if x is 5, for example? And most people get it wrong. I got it wrong. But this is actually what happens, because it's search and replace before you compile, So you get a very strange, with 5 you get 30, I think, or such, which is an impossible solution if you pass it, a number, or you would think. So that's an example why not to use pointers. This is another example. This one is from, so yeah, the title of the slide is Death by Macros. This is from an article called Death by Macros. This is a piece of code from, I don't remember. But basically, when somebody would do crazy stuff with the macros, sorry, they would give them this piece of code and tell them, hey, explain what this does. And the highlighted parts, and I missed some of them, but the highlighted parts are all the macros and such, and this is very difficult to understand code. So yeah, so why are pointers? Yeah, so pointers are nothing, so they're not a duck and whatever. So yeah, so this, for example, so this is 4 or 5 pointers, 4 or 5 macros, sorry. And this unrolls to something like this, which isn't very interesting, but I want to show this one, because this is the same one. These are the exact same macros, but as you can see, you know, the destination type above is a float pointer, and the destination type below, you know, is a byte pointer, you know. And macros don't care, you know, they just are type agnostic, you know. So to translate this kind of stuff to Java takes a lot of work, you know, you have to do it for everything and such, and annoying shit. And yeah. So C++ joke. So C++, you know, same way we worship camel case in Java. The C++ people, they worship and believe in something called Hungarian notation. And the Hungarian notation, the idea behind it is to be a descriptive notation. I find it not descriptive at all, but this is a simple example, you know. So this, the one in orange, that's a Hungarian notation, and you know the M underscore, and they really do this, you know. So that signifies it's a member of a class, you know. And then the P, it's a pointer, you know, and then S is Z, you know. It's a 0 terminated, it's null terminated, you know, it's a string null terminated string, and then you get the name, you know. And people go overboard with this kind of stuff. So this is an example of the one on the right below there. So that's an example of a very fucked up one, but you know, people do this. And you know, we don't have that we don't have it at all in Java, I think. Maybe in the early days. And I'm grateful for that. I could never get used to Hungarian notation myself. Maybe other people that could, but okay. So yeah. Oh yeah. So, so yeah, Hungarian notation is evil, but like I said, camel case is also kind of evil, you know, especially in Spring, for example. Those guys are notorious. But this is an actual class name in Java. I'm not sure if it was removed or not. And yeah, this guy wrote a cool post about it, so I thought I'd share it with you guys. So, but yeah, so Hungarian, so camel case can also go overboard. Yeah, should I explain unions? Yeah. So union is something very strange in C++, and I thought I understood them, but recently I spoke to some C++ developers, and then I knew I didn't understand them. So union, I thought at least, they were like a class, you know. So you can define multiple members of a union. So basically a class with multiple members, but all the members overlap in memory. And you basically just use the largest amount, the largest member. So in this case, you know, the int is the largest member, 32 bits. So this union is 32 bits. And if you call D, C, B, or A, which from the struct, you know, they will overlap with the int, you know. A simple example to do it with an IP address. So that was what most people say unions are useful for. But actually, you know, and this I got from a C developer that's been doing it since the 70s, and he said, now unions were actually used for polymorphism, you know, and inheritance and stuff, because in C, the older language, he didn't have any of this stuff. And so you had to be creative and you did it this way. So that's that. So why do I hate unions? That's a good question. This is a cool picture I made. And some of you might recognize it, but okay. So union within union. So this was a union in the game. A very extensive union, as you can see. And, you know, it has, you know, when you see the asterisk, this is a pointer, and asterisk is pointing to a pointer and such, or two-dimensional pointer, yeah, if you will. And the worst part, can I do this? Yeah, was this one. So this basically, within the union, you have a type of your own union, you know. And this fucked me up. This, I think, took like 2-3 weeks 2-3 months, I think, to get this right, you know. So every time I would write it, and then I would run it, and it would break somewhere, and I would debug. Okay, let's rewrite it and such. This was hell to do. And this is one of those parts. It's working. I'm not ever going to touch it again. Never, ever. And also, so while I was rewriting this in Java, and usually I run, IntelliJ and I run Visual Studio next to it, and debug both and such. And I'm not sure why this is so, so a lot of this stuff, it doesn't actually get used even in the game. So I'm not sure why it's in there. Maybe just, to make fun of people who look at the code. I'm not sure, but it's, so this is why I hate unions. This is why you should hate unions. So yeah. So this is something in between, I think. It's not really that I miss it, but it could be helpful, And the last time I did the presentation, somebody really hated this part. The destructor, obviously. So Java doesn't have destructors. And the destructor in any sane language is the opposite of constructor, So in the older languages, you had to manage the resource yourself. So if you, when you initialize an object, you say, knew this, knew that, and whatever. But at some point, somebody has to clean all that stuff up. And in older languages, you did that yourself. And Java does all this stuff for you, which is cool, Until, you notice that people, so this is from the Doom engine, of course, this is one single destructor, They do all this stuff, You shut down threads, you stop sound and whatever and such. Because this is the compiler does this for you, So you basically, you misuse the compiler for your own benefit. Instead of calling a method, close, shut down, or whatever, you do all this kind of stuff in a destructor, And you only have to destruct the object, which you're already going to do. So it's cool, It can be helpful, So yeah, Java doesn't have this. We had finalize, which is deprecated for good reason. So don't use finalize. But we also have auto-closable, which is a cool idea, But you always have to do it with a try with resources and such. So that's kind of annoying. But it's the same idea, So the reason they introduced auto-closable in Java was this actually, If you, I don't know, you create a new file input stream or whatever, you don't want to do it, in the final and whatever, and always close it and such. It's annoying. Who wants to do all that shit? So yeah, to introduce it, and destructors can be helpful, I think. Default arguments, yeah, it's a very simple one. So yeah, you can do this kind of stuff. The line on top, you can do that in C++ and other languages as well. Just say, if I don't give a y, then the y is this value. If I don't give an x and a y, then it's like that. And yeah, the code block below, that's kind of like the simplest way you could do it in Java. Maybe it can be simpler, I'm not sure, but so that's annoying. Or it could be helpful. Yeah, this one also gave me a lot of trouble last time I spoke about it. So let's begin with the why, actually. So the reason we can do this kind of stuff in Java is because string is immutable. And the idea that string is immutable is cool and it's uncool, because string is the only thing that's immutable in Java. From the primitive type, now not from the primitives, all the primitives are immutable, but from the objects you have in Java, string is basically the only immutable one. And it's very annoying. And because string is immutable, you can do this simple kind of stuff like what we do here, in the part at the bottom. So this is C++ code, and you just say, okay, I want to make this hello world, and just insert it at that location. In Java, you have to do that thing, the ugly thing at the top. And I'm very certain a lot of us, I still do it actually. You can be creative and do it with a string buffer or a string builder or whatever, but under the hood they also do this, so it's not very pretty. So I'm not going to rant about that anymore. Yeah, so this one I really miss in Java. Inlining is basically, so Java does inlining, but it does it for you out of the JVM does it for you. You can't force it. And inlining is basically, when you call a method, that function call, it wastes CPU cycles and time and whatever. And by saying I want to inline this method, you basically copy paste that block of code and put it within the place it's called from. Java has this, but you can't control it, It has a lot of parameters. I don't know. The method has to be a certain size. It has to be called, I don't know, 10,000 times or more. And then the hotspot inlines it for you. I think Graal has more options for this kind of stuff, but Java out of the box doesn't. And for games, it's very important. At least I think it's very important because the Doom guys did it and they created a great game. So I assume it's important. So yeah, I'm not going to talk about this anymore either. Yeah, it's a weird list. Anybody know the answer to this one? Very shy people. Okay. So one is true and one is false, and you can test it out. But okay. So this is one I talked about before, because we don't have pointers in Java, you miss on a lot of easy debugging techniques. So in C++, if you have like, I don't know, something, an x for this, an x of an object, for example, and you want to know when this is changed. In C++, you can just watch that memory address because you can point a pointer to that memory address, in layman's terms, and just watch it. And the moment it's accessed or changed or whatever, the breakpoint goes off. In Java, we don't have that. We have something similar. It's called, I don't know, a field modification breakpoint or something. So this screenshot is from IntelliJ. It's very slow. That's really why it's not very helpful. It's very, very slow. So when I use this with the game, I never get to the breakpoint. The game becomes so slow, so it goes from, I don't know, 60 frames per second to half a frame per second, and it never gets to the breakpoint. But when I use it with other applications, so with just a piece of code, 100 lines or something, it does get there. So it can be helpful, I guess. And I've only seen this in IntelliJ, and I asked the IntelliJ guys before, so people, why is this so slow and such? And they told me, it's not really our fault, So this is not a feature that IntelliJ built. This actually exists in the TI, the tools interface of Java. That's where all the debugging stuff and then instrumentation stuff comes from. And it's just slow, and nobody touches that stuff anymore because I don't know why, actually, but so it's just slow, and we can't do anything about it. But yeah, it's there. You can use it. It's cool. It's not the same as this. And setting it up is also very difficult, or much more difficult than this. So yeah. This is another one. Yeah. So this is the widening primitive conversion. You can put a float within a double, and you can put an int within a double, or int within a float, or a long within a double, and such. And the compiler would just allow it. To be fair, other programming languages do this as well, but it's very error-prone. If you look across these things, some of them are the same when you cast them back, but some aren't. So the float sum, for example, when you cast it to a double, it gives a different result from the double sum, which is basically the addition of the two floats. And I've had a lot of bugs around this kind of stuff, and it's very, very, very difficult to find. There's no really real solution for this. I'm just, ranting to you fine folk, so early in the morning. So yeah, this is annoying. Yeah, this is a cool feature in Java, actually. And surprisingly, not a lot of people know about this. So just last week, somebody was asking me, wouldn't it be cool if Java had this? And I told them, yeah, it already has this, actually. But he was using Eclipse, and it was difficult to find in Eclipse. So this is in Java, when you set a breakpoint, you get a call stack, which is the yellow part on the left. And you can just basically say, okay, I want to, at this breakpoint, I want to drop the frame and go back to the previous point. And this is very helpful sometimes, and can be very helpful, So when you set a breakpoint, but you set it, for example, a couple of lines too late, and you want to say, okay, now I want to go through those lines, so you drop the frame and then just, step in step by step till you do what you want. The biggest problem with this is, I'm not sure if there's the only problem, but the biggest problem at least is that it only drops the frame actually. If you changed anything outside of the context of that frame, it doesn't really care about that. So if you call a function on an object, for example, and you change one of the members of the object and you drop the frame, that member won't be turned back. So if you did x++, it's already incremented. But everything you do within the function, within the scope of the function, that will be turned back. So be careful. C++ has another one, which is much better. So this is from GDB, and it's basically, you can reverse step. So as you step into something or step over something, you can step back, And that one really turns everything back. It has some limitations, but it's kind of better than the Java. I'm not sure if it's better, but it's something different. And yeah, who knows? Maybe we'll get this in Java someday. Yeah, thank you. Yeah, so this is the floating point operator precedence one I talked about. So the operator precedence one I talked about when you overload operators. So you already have operator precedence for everything that already has operators. Not everything, because string also has operators, but it doesn't have precedence. And sometimes it matters actually what the order is you do things in. So this is an example with specific values, of course, not any value will do this. But mathematically speaking, these two statements should be the same. A multiplication and a division, doesn't really matter what order you do the things in. Kind of, yeah. So these two will return different results. And this one, yeah, this one as well. This is what with multiplication and addition, which is even worse, So mathematically speaking, both these statements are the same. This is an actual bug I had in the game. And I think BLA2, from the one on the right at least, I think BLA2 is 0, while BLA1 is an actual value, or vice versa, I don't remember actually. And yeah, this is very tricky stuff, and this is, I'm not going to say undebuggable, because I found the bugs, but it's very difficult to debug it, because you're not really doing anything wrong, except being stupid, So that's, here's a better example with actual values, yeah? With actual printouts of the values and such. So who would actually imagine that these two would give different results? And yet they still have different results. And the reason for this, I didn't explain the reason, but the reason for this is because floating points have limited precision. You only have 32-bit precision. And at a certain point, when you do something, you have to round it up, or the JVM does it for you. And this also happens in C++ in most languages. It's just an IEEE thing. Huh? It's just how the standard works. So if you do an operation, you round it up, and then you do another operation on the rounded up version value, you get these kind of errors. Granted, a 0.00001 isn't much, but it's still not the same value. And this is another one, also with addition. Same fuck up, And again, for our day jobs, not very important, but when you're doing game, you're only working with floats and floating points, and sometimes. So this one, the one on the right, there's an actual bug I had. I thought I would be creative, and rewrite it mathematically instead of a minus b plus c. I would do it like this, because when you're doing 600,000 lines of code, you get bored and you try to amuse yourself, and you do this kind of stuff. And months later, you find a bug, where you're, I don't know, instead of going right, you're going left and dying and such stuff. So it's important stuff. How much time do I have? So yeah, conditional breakpoints are also pretty cool in Java. All programming languages, most programming languages have them, except in Java. And I didn't know this myself. I only discovered it when I was doing the game. They're very, very, very slow. Usually, because you don't go through breakpoints, go over breakpoints a lot. In your application, so conditional breakpoint is when you set a breakpoint and you set the condition within the breakpoint itself. And this is the other one. So this is a normal breakpoint, at least the example is, And in Java, so this is another micro benchmark. I did a comparison with a simple loop. So the first experiment is instead of I is even, I is odd actually, no, I is even. I put that in a conditional breakpoint, and this is the other example. I did a normal breakpoint and I put a condition in the if statement. And turns out it's about, if you can believe this, it's about 180 times slower, So I know this is probably a little bit exaggerated, but I was too lazy to redo the slide. But it's much slower, So I noticed this a lot in the game when I debug stuff. I always use an if statement and just compile the code. It's much easier. And it's much faster, you know. And the reason it's much faster is when you could do conditional breakpoint, your debugger goes into interpretive mode, which is very slow, you know. So beware when you do this kind of stuff. It's very slow. I hope I have enough time for this one. Yeah, so let's just skip this one. So I'm gonna show you the progress of the game. In the meantime, you can ask questions because it takes some time to start up. So any questions? Oh, sorry. Yeah, yes, sir. I'm running the game every time I change something. Unit tests wouldn't be very helpful. There are some unit tests, but they're basically some basic math stuff, and it's not very, very helpful for this kind of stuff. Yeah, maybe they could be. I'm not sure. So yeah. In general, people in the games industry don't really do unit tests. This game did have some unit tests for some example. I'm not sure why. But they were only for the math library. And the math library is, I think, maybe 2% of the whole code. So yeah, so that passes. But how we use it doesn't pass. Or how I use it doesn't pass. So yeah. So we don't have sound. I'm not sure why, but... so yeah, I show everything in wireframe because I'm missing a lot of textures and blending. So stuff would still be too dark. So yeah, this should say Doom 3, but like I said, I have problems with blending. Any other questions? I can't see you. Can you raise your hand, please? Yes. Mostly it's just transforming the code. Some refactoring, but most of it, I think 60% just translating code and 40% refactoring and 100% debugging. So yeah. Any other questions? We have like 2 minutes. This is much better with sound. Yeah. Not yet. I don't expect it to be much of a problem, to be honest. I mean, it's a 10-year-old game, as you know, so it's not as if I'm doing Doom 2016 or so, for instance. So I'm not really seeing much of problem right now, but I'm also not, you know, doing a lot of, so I'm gonna show right now, the game is not very, very playable yet, you know. But the memory footprint is much larger, of course. So right now, the average memory footprint is like 1.5 gigs. And I think when this came out, it was like recommended memory settings 256. So, but it's not optimized yet. I'm just, you know, doing the basic stuff. I'm trying to keep it as is to make it easier to debug it because I compare it a lot to C++ code. And if I'm too creative, I lose that. So, yeah, I had a. So as you can see, the heads are floating somewhere else. This is one of the things I broke, but I'm not going to fix right now because I'm trying to fix something else. Yeah, sorry. That's. I mean, it's a horror game. This is much more scary, huh? So, yeah. The face should have an angry look right now, but because he's not glad that he gets to go to Mars. Any other questions? We have 1 minute. I'm going to show some. Yes, sir. Yeah, I tried that. It was not a good idea. It was really not a good idea. Yeah. The scale of the game, if you're going to do that, it's just too large. And when you do it, you're basically rewriting the engine if you're going to do that. Because this is one of the first games, I think, for the company at least, where they actually were using floats. Back in the 90s, most of people used for you know, geometry, so you just use ints and you rounded stuff up, and that was much easier. So this one is float based, and yeah, doing that is yeah, it's hell. Sorry. So yeah, it's much better with sound, even if it is broken. Yeah, I can do this. Yeah. Yeah, this is you know, it's kind of scary. Ooh. Yeah, I don't really remember where I should go. I think it's like this. Can somebody tell me if I'm out of time? People in the red shirts. In the back. Okay, I'm just gonna play. If I can remember what I should do. Yeah, scanner is ready. Yeah, this thing should move up and down. It's not moving right now, but who cares? Right? Yeah. And am I out of time? I'm out of time. So I'm gonna kill myself, which I'm very proud it works. Yeah. And he makes an "oh" sound, but you can't hear it, so sorry. Thank you very much.